Today we'll learn how to add matrices and also how to multiply a matrix by a number, which we'll often call a constant or a scalar. First, let's make sure we understand what it means for two matrices to be equal. We say they are equal if they are the same size and if all the corresponding elements are equal. So, in this example, which matrices are equal? It looks like B is equal to A because they are the same size and all the entries corresponding are the same. There are no other matrices here. There's no other pair of matrices here in this group that are equal. Adding matrices. This works exactly the way that you probably would have guessed had you just guessed instead of waiting for me to tell you. They can only be added if they are the same size, and in this case we add the corresponding elements in the matrices. So if we take this square matrix, this 2 by 2, and add this 2 by 1 column matrix, this addition is not possible because my matrices are not the same size. Now here we have two 2 by 2 square matrices, and so the result will also be a 2 by 2 square matrix. And so in the first entry we'll have 2 plus 1. In the second entry of the first row we'll have 4 plus 2, adding the corresponding ones, then 4 plus 3, and then 2 plus 4. You probably wouldn't write this step once you know how to do this. You'll just add those in your head and you'll get 3, 6, 7, 6. Okay, let's add these two 3 by 1 column matrices. Notice they are the same size, so that means we can indeed add them. We're going to add them exactly the way you would think. Negative 1 plus 4 gives me 3. 2 plus negative 5 gives me a negative 3. 3 plus 6 results in a 9. That's how we add matrices. We should note, because of the way we add the matrices, that the addition of matrices is associative and commutative. Commutative means we can add them in either order, and since we were just adding the corresponding elements, and real number addition is commutative, then that means we could have added the matrices in either order. If we are adding three matrices together, we have the choice of which two to add together first. If you add three numbers, you don't really add three numbers simultaneously, although you may only write one answer at the end. What you're really doing is either on paper or in your head, you're grouping two of them together and then adding the third. It works for real numbers, and therefore, because matrix addition only involves adding real numbers, it's going to work for matrices as well. A zero matrix is a matrix with 0 in all the positions. Here is a 2 by 2 zero matrix. Here is a 3 by 1 zero matrix. That's a column matrix. Here's a 2 by 3 zero matrix. Remember, when we talk about the size, we always list the number of rows first and then the number of columns. Subtraction of matrices is going to involve the negative of a matrix A. We're going to call the negative of a matrix A, we're going to write it as minus A or negative A, and it's going to be the matrix that has all elements that are the opposite of the corresponding elements in the original matrix. So if I have an A of this, okay, what will negative A, or the opposite of A, be? Exactly what you would expect. Here we'd have a positive 3, negative 2, negative 1/4, positive 5. To subtract, what we're going to do is we are going to, in order to subtract A minus B, we'll define that to be as A plus the opposite of B, or negative B, which is done by taking the opposite of all the entries the way we just did. You'll only be able to do this if your matrices are the same size. So what this turns out to be is we just end up subtracting the corresponding elements. So here we're going to do 1 minus 0, which is 1. 2, let me write it out a little bit. 2 minus negative 2. You've got to be a little bit careful with your minus signs here. Here we'll have minus 6 minus negative 2. Negative 3 minus 4. 4 minus 6. And 5 minus 5. And so when we simplify that matrix, we're going to get 1, and then 4, and then negative 4. Second row we'll get negative 7, negative 2, 0 when we subtract those two matrices. Multiplication of a matrix by a number. We call this scalar multiplication. We think of a number, it's often called a scalar to distinguish it from a matrix or a vector. And so here our number is k, matrix is capital N, multiply km. All we're going to do is multiply each element of m by that scalar or number k. So here we're going to multiply 4 times 1, 4 times negative 2. Again, this is one that works probably exactly as you would have guessed if you didn't know any better. And of course, once you know how to do this, you probably won't write that step that I just did. You're going to do 4 and then negative 8, 0, 12, 28, negative 16. That's scalar multiplication. And those are our basic matrix operations. Matrix multiplication is a little more complicated, but we will also learn how to do that later.